now. I pushed the red button, Michael. I did it.
Hello, everyone.
It isn't a red button. It's actually a green button. And then once you've pressed the button, then it switches to a red button to stop it.
It's true.
So there you go. The shiny candy-like button. Okay, so I'm about to say hello to people. So if you want me to say hello to you, you've got to post a comment in the live chat, and I will do so. Oh, it's about to happen. So Pamela and I were talking about this before the show that this is the herring run here on the west coast of Canada, and it is apparently it's the largest biomass migration in the world, and it's like literally centered right here. And so we get, I posted a picture into Slack to some of the team. There's a picture there, and you can't see it, but it's like filled with little specks. And there's 60 eagles in the picture all at the same time. And then you'll get like hundreds of thousands of seagulls. And when the herring run happens, when they lay all their eggs and stuff, you'll get herring roe, like eggs on the beach, 3 inches deep, 4 inches deep. It's like snow. Yeah, it's amazing. Yeah. So anyway, and the actual moment that the herring run starts is, it's around this time. It can be a little earlier, a little later, just depends on the temperature of the water. So every day we go out and sort of look for where it's happening. But it's, sea lions, pods of sea lions out there. I'm not sure if that's the right term. A murder of sea lions, killer whales, eagles, seagulls. It's mayhem. It's awesome. Elad says, I thought eagles are corpse eaters. Yeah, dead herring washed up on the shore, and the eagles are all over that. So that's exactly right.
And eagles will happily fish. We get them along the Mississippi, and they dig grabbing a fish out of the water because the fish don't see it coming.
Have to. You want to see lots of eagles, you just go to the dump.
That's true.
Yeah, but my wife just won't. She won't go. I'm like, come on, you see them so close. It's the best view. She's saying no right now. Okay. So
they also steal chickens.
I'm going to say hi to Adam Synergy, David Joseph Wesley, Elad Avron, Giselle Sabarin, G-Man 351, Guido Bieber, Helge Bjorkog, Jay Haskins, John Cross, Johnny Zed, Michael Collins, Michael Jobin, Michael Thompson, Nancy Graziano, Nicole Gatnikar, Ott Koppelma, Phil Wilcox, Preston Pendergraft, Richard Strazel, Rinstro, Ross Betts, Sylvan Westby, Stephen Walker, Thomas Traniker, Tom Nathy, Tom Van Scotter, and Umu. So welcome to Astronomy Cast. If you have no idea what it is that you have stumbled into, we are about to record a live episode of Astronomy Cast. Take about half an hour and do that, and then we'll stick around and yak with you guys and answer your questions about space and astronomy. Valdegas wants to know if they're the only one who's anonymous. I don't know.
Svev Dust Bunny isn't exactly telling his name either.
Yeah, exactly. Bolt Crank, welcome to the first time you get to see it live. Welcome. How awesome is that? Let's see. Any other questions?
Folks are asking about the eclipse. It is over Indonesia, Malaysia, Micronesia. And I think there is also visibility from part of Hawaii and out over the Pacific Ocean. That's going on right now. And I'm going to be actually posting probably later today information on if you want to come to St. Louis for the 2017 eclipse. We're going to start gathering information, and we've confirmed the hotel we're going to be using. So stay tuned for the next great eclipse, this time over more of a continental instead of an oceanic part of the world.
Count me in. I'm in.
That's good.
Yeah, let's do it. Speaking of things that we do, why don't we record an episode of Astronomy Cast?
That sounds like a thing to do.
Okay.
I'm ready to record. Are you ready to record?
I am so ready to press record.
Okay. I am pressing record.
I'm also pressing record.
Hi, Preston.
Hello, Preston. All right, here we go. Astronomy Cast, episode 406, Stellar Cannibalism. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. I was mentioning before the show that it's the herring run season here on the west coast of Canada, and it's wildlife to an extent you just can't even imagine. Hundreds of eagles, hundreds of thousands of seagulls, herring roe piling up on the beaches, like snowdrifts. It's sea lions, whales. If you ever want to see like the greatest accumulation of nature ever, check it out, West Coast in March.
The Mississippi estuary is awesome, but nowhere near that awesome. You truly have gotten the massive, awesome birds and mammals.
Yeah, and we get two of them. We get one in the spring, and we get the one in the fall when the salmon do their run up the river. And it's again, the eagles all come back and feast. But yeah, it's a great time. So just to want to give people a reminder that we actually do Astronomy Cast as a live show, and so we actually the show actually goes for an hour. Now we only put out a half an hour of it on the podcast, but if you want to join us and like hang out for the chat and talk to us, and we'll answer your questions, we do the show live every Monday
with occasional exceptions.
With occasional exceptions at noon. And so the way you can join us is just go search on YouTube for Astronomy Cast. You'll find our channel. Make sure you subscribe to it, and then give yourself notifications to be notified when we do our live show, and we will be glad to have you join us, and then we'll answer your questions. I'll say your name. It's a good time.
And if you're listening to this live on October, if you're listening to this live on March 14th, this is one of those lucky weeks when we're not recording on Monday, because I'm actually going on like my first vacation in years. So we'll probably be recording on March 16th, which is why you subscribe on YouTube, so that you get these notifications for when we do these weird things.
That'll be me on April 4th. FYI.
Yeah, we take turns.
Yeah. Okay, so most of the time, stars hang around for billions of years. But the universe is a big place, and anything that can go wrong inevitably does. And today, we're going to talk about what happens when stars come together. It's violent, but fortunately for you, also interesting. So now, just to let's do a big disclaimer, right? Like, the events that we're about to talk about happen so rarely that you have to see across an entire universe and catch them occasionally happening. But when it does happen, kaboom.
For the most dramatic kinds of cannibalism, it turns out, just like mosquitoes are constantly out there doing their little happy vampire thing, turns out cannibalism is actually fairly common throughout our universe if you look for the less dramatic forms.
Less dramatic ones,
just grabbing a biteful here and there, not eating the whole body.
So today we're going to talk, I guess, about how stars come together. One star feasting on another star, stars colliding, and what happens and how you can even detect it. So let's start with, as you said, sort of the more common variety. Let's talk about some of the situations. And I guess to set this up is to talk about how common actual binary star systems are out there in the universe, right? It's not just solitary stars. Most stars are in multi-star systems.
Yeah, the running joke is 4 out of every 3 stars is in a binary.
I've never heard that before. That's awesome.
The way that works is every 3 stars that you look at with your eye on the sky, it turns out that 2 of those so-called single stars are probably actually 2 stars. So when you think you're looking at 3 stars, you're actually looking at 2 binaries plus 2 binaries plus a singleton, so 5 stars. It's fairly common, and with all of these stars appearing in pairs, it turns out that sibling rivalry is a rather real thing, and gravitationally, they sure like to yank on one another's outer atmosphere.
Right. Okay. So set this up then. In the more common binary stars, they're fairly far apart, right? That they're not actually transferring any matter. It's really just down to, they're gravitationally connected and they're orbiting one another, orbiting a common center of gravity, but they're far apart, and so they'll just go for their billions of years. One will die, the other's going to die.
They're a nice, happy, wide binary star.
Right. Okay. So how close do they need to be before things start to happen?
It depends on their state of evolution and how massive the two stars are. One of the most common situations is you have two stars that are fairly run-of-the-mill. One is maybe several times the mass of the sun. The other one is more like the mass of the sun. And the bigger one evolves faster. That's just the way space works. We've talked about this in a million different episodes. But because it's evolving faster, it hits that point in life where it goes from happily burning hydrogen in its very core to, bloating out into a red giant star. And it's this bloating period that gets it into trouble. If the two stars start off maybe a couple solar systems apart, well, as the one bloats up, it's going to get bigger and bigger. And eventually its outer layers might get just close enough to that sibling that is sitting there being a main sequence star that the sibling is able to start yanking off that material and bloat up to become even bigger.
Well, let's take a look at, for example, our solar system, right?
Mm-hmm.
So the sun right now, teeny tiny, a million kilometers across, or 1.4 million kilometers across. But when it hits that red giant phase, it's going to be like as big as the orbit of the Earth, maybe?
Probably a little bit bigger than that. Now, luckily, conservation of angular momentum and all of that, and mass loss and factor and all of these things, the Earth is going to migrate outwards. So in all likelihood, according to all modern models, well, not all, but many modern models, the Earth survives being absolutely consumed because it's moved. But where the Earth is now, the sun will be later.
Right. So but the Earth is whatever, 150 million kilometers. So we're looking at really a factor of 100 bigger that the sun is going to get. Right. Although maybe a factor of 50, sorry, because one, it's a diameter, the other case, it's a radius. But anyway, it's going to get way bigger, right? Dozens of times bigger. And so what could have been, if it was just two stars, these two stars orbiting some common point, and they were 150 million kilometers apart, they would, it's that when one dies and that it gets that envelope that's so much bigger, that's when you get those interactions. Okay, so you've got these two stars. One dies first. It expands out.
It expands out.
It hits
middle age.
It starts to burn some helium and hits that red giant phase, and the other one starts to, go through its outer atmosphere.
Starts to eat it. So we have what's called a Roche lobe. This is if you have a star and you have a star next to it, they have this combined gravitational field they're creating. And at a certain point between these two stars, a particle that just sort of set down, it's going to be gravitationally attracted equally to both of these objects. Now, you can trace out an entire shell where something at that shell is just on an equally potential surface is what we call it. And if it goes past that shell, it goes to the other star. If it stays inside of that shell, it stays with its parent star. Well, when you get two objects close enough together and one of them decides to puff up, it can puff up so that matter starts spewing through that Roche lobe. It's called filling the Roche lobe, overflowing the Roche lobe. And now you have matter streaming from one star off to the other. Conservation of momentum means that it usually goes through a disk on the way to the other star. And once it gets there, that other star does what it will with it.
So I'm trying to sort of imagine the situation, right? So we've got the one star, it's puffed out into a red giant. There's this stream coming off the star that's going almost like a river to the other star, and the other star is accumulating this matter into a disk, kind of like a black hole or kind of like a protoplanetary disk, like a galaxy, and it's accreting this material onto the star.
Yes.
Shenanigans?
All sorts of nifty, neat things happen now. So, in the least violent of cases, you have, in the end, what we call a blue straggler. And it's been a long road figuring out what is up with these blue stragglers. So, when you look at a globular cluster, population of really old stars, even some of the oldest open cluster stars, what we find is there are these weirdo, why haven't you finished evolving, bright blue, young appearing stars where they have no right to be. If you have a cluster of stars, all the stars should have formed at the exact same time. They should all be evolving in lockstep according to their mass. Bigger ones doing interesting things first, smaller things doing interesting things later. But we keep finding these random blue ones, which we call blue stragglers because they're straggling in their evolution. And for the longest time, we didn't know where they came from. Was it the merger of two stars in a binary? Was it cannibalism? Was it something else? And in recent years, people have looked at more and more of these blue stragglers with high resolution spectroscopy and seen that that blue star was doing the dance of a binary. It's the same thing that we see when we're looking for exoplanets, that little tiny wobble that's caused by getting gravitationally yanked to and fro. And in looking at these stars, it appears that mass was transferred from the more massive companion onto the less massive one when that more massive star became a giant. And it allowed the other one to just hang out on the main sequence all that much longer.
So, you know, when you say hang out on the main sequence that much longer, you mean it's like it's gathering fresh fuel.
Yeah.
That it can then use and continue to burn. And so when it would maybe have died, it now gets a second chance at life.
It ends up being able to support a larger core, have more matter down in that core, and just, yeah, get a second chance at life. These things look like young stars in almost every way. It's
right,
their
that's what I was going to call it.
Lithium, but yeah.
Like, why do we call it a blue straggler?
Because all the other stars in the family have already evolved. And so why is this star still straggling behind the crowd? Why hasn't it evolved on like everybody else? And it's because it got this second chance at life.
Okay, I see. So you've got like this cluster that you would assume has all formed together at the same time. But and as we know, right, the most massive stars detonate a supernova first and they're gone. And so you shouldn't see any of these young, hot blue stars. They should all have died a long time ago. And yet when you look in this cluster, you see these stars that have no place there. And so instead of actually being young stars, they are actually older stars that have been fed by a companion and they have become rejuvenated like some horror movie.
Yes, they're zombie stars. We need to start calling them zombie stars.
Right. But I think, I think of some like, some older star, feeds on the life force. Vampire stars, I think, is probably better. At least feeds off the life force of its companion star and then gets a second chance at youth. It's a science fiction fantasy.
It comes right out of the DC universe. It's the old evil killing off the younger one to have immortality.
Right. Okay. And so this is if they are, I guess, if this happens in a reasonable period of time. What other kinds of, I asked for some shenanigans. So what else can happen in this kind of scenario?
Well, so the blue stragglers are like I said, they're the boring ones. We also have the Algol variables that we're actually catching them in the process of the mass transfer. So the blue stragglers, they've finished, they're done. They ate everything there was to eat. The Algol variables are variables that we actually see them in the process of consuming their nearby neighbor. And we call them this because Algol itself is one of these kinds of variable stars. So again, in this case, it's the one star became a subgiant and it transferred its mass to the lower mass star.
How much of the material will it consume? Like, will it kill the other star dead? Will it?
And it turns out that if it's the more massive star that's transferring its mass to the lower mass companion, this is a fairly stable mass transfer, and it can go on and on and on until all that's left behind is essentially the white dwarf core of the other star. So it just eats the whole atmosphere off.
Wow. But I mean, in the case of like a star like our own sun in the future, it's going to blow off of that outer atmosphere anyway, and then turn itself into a white dwarf. So it's almost like it's going through that same process, but in this case, instead of that whole atmosphere just being blasted off into space and making a pretty planetary nebula, it's donating that outer atmosphere to this other star to give it a second chance.
It's a bit of an
so horrible.
It's a bit of an accelerated process, though, because like
Right,
our
but
sun, it could hang out and be a Myra variable for a great deal of time, but instead, you basically have the neighbor just gravitationally slurping off the life. It's like an aging drug.
I'm now thinking it's more like organ donation. Right? The bigger star is just kind of giving the material to the younger star a little sooner and perhaps a little more violently than it was planning, but still. Okay, so what if those stars are closer together though, right? Like, you know, like what if one star is like literally in the atmosphere of the other star?
You can actually get shared envelope stars now and then. We're still trying to understand them. There was one case a few years ago where we're pretty sure we captured one in the act. It had the crazy name of Nasty One, and that's actually what we called it, because its classification was NAST1 from the catalog it was in. This was a Wolf-Rayet star that was in a binary system in a shared nebula with violent stellar winds. And it was impossible, and is impossible, to see all the way down into the core to fully understand what is going on. But observations with Chandra led folks to believe that this probably is a case where they're somewhat sharing this violent outer cloud of gas and dust.
If you get a star kind of within another star, is that going to act like an atmospheric drag? Is it going to are the stars going to spiral into each other?
Yeah. Well, it depends on if this is a permanent phase or a temporary phase. There are different cases where the possibility, for instance, in some of the carbon variables, where you see a star just suddenly essentially wink out, it's thought that perhaps this is a Kahneman envelope problem where you have a white dwarf spiral into a normal star, and this just messes with the outer layers of the star. In cases like that, where it's two stars in the process of merging, shared envelope, it's probably exactly what you're talking about. Nice drag, happily merge, everything goes well. There are cases where they have a temporary shared envelope, things get blown away, and then you end up with two naked cores later.
So what happens if the star spirals all the way in and, you know, hits the core? What happens if they actually merge in the middle?
That is fine. It's a bit violent, but it's fine.
Right, because you're only going to get like maybe 2-3 times the mass of the sun. You know, probably not a supernova. Okay. All right.
Yeah, it's not a big deal. You're going to get X-ray flares when they first mix, but that's okay. We know how to deal with X-ray flares. We observe them. We stare at them. They're fine.
In that we know how to recognize them in our telescopes. Like we know how to deal with them. You know.
No,
like
so the truly violent things actually don't involve the cores merging. The truly violent things involve cannibalism, where you have a small compact object of high mass violently stealing the life force off of a lower mass companion.
Right. So, but think about this scenario, right? You got these two stars. You got the younger one the bigger, hotter one dies first, feeds all its material off to the other star, right? And now it's left, and it's a white dwarf. And the stars keep orbiting one another. And then the second star dies, puts off its material, feeds the white dwarf. Now you got a different situation happening.
And there are scenarios where people have projected maybe you can go back and forth, but because of the way the angular momentum works, it's not a perpetual energy system where you constantly are bouncing an atmosphere back and forth between two different stars.
Well, no. But I was setting you up for what happens when a white dwarf is the object that's stealing material from its companion object.
Okay, sorry, I failed to recognize that.
Do you need me to do this again?
Well,
no.
so let me step back. So usually when you get a white dwarf, it's not because it's been stripped naked by its peer. Normally you just have one star that, again, it's more massive, it evolves faster, but in this case, it gets to hold on to its atmosphere, goes through normal evolution, lands as a white dwarf star, kind of like our sun will someday in the future. But for a variety of reasons, the stars may end up migrating closer together, or as its neighbor star, as the lower mass companion, much more likely, as it bloats up, as that lower mass companion decides to stop being a main sequence star and becomes a giant star of one form or another, it overflows its Roche lobe and material starts to stream onto the higher mass companion. Now, as it streams in, that white dwarf, it's just going to crush the material violently onto its surface. And the cool thing is, as it crushes that material on its surface, when that material gets crushed to the point that it's about 20 million degrees Kelvin, it's going to violently undergo nuclear fusion, which is another way of saying it acts like a lot of nuclear bombs. And via the carbon, nitrogen, oxygen cycle, it's going to happily burn kind of like the core of a star, but on the outside of a star.
Right. So you've got literally the fusion, like the core of the sun, but on the outside, on the surface of the sun. So what happens then?
Well, luckily it blows off a lot of this extra mass, and so it flares up, does its high I'm a nova thing, blows off all of that energy, and then goes back to sitting there. Now, as its neighbor star yet again bloats itself up, it may transfer a little bit more mass, and this is where you can end up with a recurrent nova kind of situation. Now, what's cool is we get to see these things as X-ray binaries. And in some cases, we actually end up with what we call microquasars. This is where that accretion disk around the compact companion has all of the physical properties of a normal quasar, except it's just around a stellar mass black hole or neutron star instead of around a supermassive black hole.
But isn't there something wonderful that happens when the white dwarf has consumed a certain amount of material from its partner?
It's true. There are cases. See, I'm thinking all about the black holes because they're cool. But if you have a white dwarf that's happily being cannibalistic and nomming on its companion, eventually, just like all the rest of us that overeat, it gets fat. And once it exceeds about 1.44 solar masses, pow! It kind of goes off as a type 1A supernova.
And I actually just did some research on this, and there's nothing left. The black hole is just gone.
Yeah.
But these, of course, the type 1A supernova, these are those standard candles that astronomers use to measure distance in the universe, because you got that wonderful 1.4 times the mass of the sun every time. That's when it happens, which is super cool.
And all of these different little compact binaries, they have amazing physics tied up with them. So we have the white dwarfs that consume too much. They go off as type 1A supernova. They are our standard candles. But then we also have millisecond pulsars are actually spinning that fast because they are in low mass X-ray binary systems. They stole material off of their partner, and that theft of material was kind of like an ice skater drawing in her arms. It spun them up so that they ended up going, hundreds of times a second around their happy little rotational axes.
So what if these things collide?
Well, that's where we get gravitational waves.
And things like gamma ray bursts and
Yeah.
hypernovae and
Yeah. It's thought that short gamma ray bursts are probably caused by the merger of neutron stars, and that's just kind of awesome to think about.
so you're not going to get like collisions, like two stars happening to collide with one another. You're going to get a situation where you've got these two stars that are orbiting each other in this really close binary situation, and eventually they spiral inward because of gravitational waves and merge with each other.
And that gives us violent gamma rays and afterglow that is very short in duration. I think we've caught them 2 or 3 times at most. And yeah, explosions are cool. And what's awesome is globular clusters are kind of the ultimate place to go looking for this kind of stuff, because while all the stars in a globular cluster more or less formed at the exact same time, the binary stars that we see in globular clusters aren't necessarily binaries where those stars form together, because these stars are so close together that they periodically swing past one another and like, oh, let's co-orbit. So you have new binary systems forming, not on a regular basis, but statistically more frequently than anywhere else. And so you have these situations where stars can end up close together. Cannibalism can end up happening not just between siblings, but between cousins. And you get all of these neat X-ray binaries and millisecond pulsars and everything else.
And, we've mentioned this many times before, which is that when we have some really great survey instruments, things like the Large Synoptic Survey, we're going to see these kinds of events with more regularity because we're now scanning the whole sky and we're going to be looking at any brightenings, any movement, any explosions. It's a great time to be in this field of science.
So it's a neat future where we get to finally start learning the actual frequency of all of these different blue stragglers, of recurrent novae, and well, thank Chandra and Fermi for all of the millisecond and other X-ray binaries that are out there.
Awesome. All right. Well, thanks, Pamela.
My pleasure.
All right. I'm going to stop. I'm going to save.
Yep.
Into the Dropbox. Preston needs to clean up.
Okay.
There's a million.
Today is 4:06. So this is the point in the show where you get to watch us save before we accidentally lose the show.
Yeah.
We're sorry that you always get to watch this boring stage of every single episode. But you're grateful for this boring stage.
This is how the show gets to you. Yeah.
Right.
Okay.
So I see that Willem van de Beek is asking, so one of the two stars cannot cannibalize itself into a black hole. No, it would rather explode instead. There's some good jokes in there. Kill the Dropbox. Okay. Yes.
I just killed the Dropbox. I did it. I just killed it.
Elad Avron is asking, have you ever actually lost a show? Yes, we have. And actually last week, my audio was corrupt and we stole it from YouTube. So really? It turns out, oh yeah. YouTube is our savior now that we record live. But before we were recording live to YouTube, once or twice we lost entire episodes and just had to cry.
Yeah, we put a lot of emphasis in not losing shows. We learned that lesson the hard way a couple of times. And one of the other advantages of doing this on YouTube is exactly that we don't lose. We have a backup that we can always go to as well. And then sometimes the YouTube show gets corrupted. But fortunately the main one, so we've actually had to go the other way sometimes, and you have to rebuild. You can only have the audio, but we can still kind of piece together a show and post that. So yeah, no, absolutely. Let's see.
question. I recently re-listened to your episode on gravity and competing ideas of gravitons versus curvature in space-time. How does the recent news out of LIGO impact those theories? It doesn't. That one doesn't. We're still stuck.
As Pamela has grumpily informed us for quite a while, we've known about the existence of gravitational waves like since the 70s. So that gravitational waves have been directly observed is no surprise because we knew they were there from the pulsar observations back in the 70s. There's nothing new with the gravitational waves. It's just that we're now seeing them directly as opposed to indirectly. Does that capture your grumpy attitude, Pamela?
Yeah. Yes, it does.
All right, good. Because gravitational waves, the direct detection is awesome and super amazing. And we're all so excited and we can't wait for the next kinds of observations, especially Lisa.
Yeah, I do.
Yay.
Look forward to Lisa.
Adam Synergy is asking, what kind of stars could form a Thorne-Zytkow object? Are they?
I have no idea what that is, so I'm Googling.
Me too. Hold on.
It contains a supergiant neutron. Is this theoretical or observed? So it says a Thorne-Zytkow. I'm reading Wikipedia, folks. Is formed when a neutron star collides with a star, typically a red giant. And there are candidates. There are 3 candidates. There are Corona Borealis variables. This is actually what I was mentioning. I didn't know they had this name. I thought when I said carbon variables, so there are some stars out there that periodically radically dim. I thought it was a white dwarf getting sucked in was the last theory I'd read, but I haven't read the theories for a number of years.
Right, but the idea is a red giant with a neutron star at its heart. So I guess back in the day, it was a supermassive star and a regular mass star. The supermassive star dies, supernovas, turns into a neutron star, falls within the envelope of the red giant when the second star goes, and then the star just goes down into the middle of the red giant and then just hangs out in the core. Crazy. That's yeah. Theorized by Kip Thorne of Interstellar fame. Also,
that explains the name. Yeah. I need to read about this.
Yeah, that was really cool. That would have been a great addition to the show. How come you didn't?
Because I don't know everything.
No, Adam should have, of course, there's a million of these. That was great, Adam. Thank you so much. Sev Dust Bunny asks, I know this is not fully related, but since gravitational waves have been confirmed, have we got a frequency? Could it be part of the EM spectrum like heat or X-rays?
No, it's just completely different stuff. It's sort of like sound waves aren't part of the electromagnetic spectrum. Still waves, just a different kind of wave.
Yeah. And so they will have a frequency. Somebody played, you can play the frequency of the gravitational waves and hear the sound of what they would sound like if they were, slowed down or sped up, depending on the size of them. But it's a completely different spectrum, right? This is the sound of 2 black holes merging. That is the sound of
and that's
neutron
just
stars.
It's the false audio equivalent of making an X-ray image pink. That's false color. Yeah.
Sev, it's just
a separate
else.
Spectrum.
Yeah. It's not even a spectrum. I mean, it's not like, when you have electromagnetic radiation.
Different gravitational waves it's like hearing, you have the frequency spectrum of hearing with high-pitched smurfs and low-pitched giants and tubas and piccolos in there somewhere. Gravitational waves come in a variety of different frequencies, so you can sort of imagine they have their own spectrum depending on what's forming the waves.
Yeah, I mean, you have organs in your head, right? You have your ears that hear sound, And if the sound waves are moving very slowly past you, you hear a very low rumbling. And if the sound waves are moving with a very high frequency past you, then you hear very high pitched sounds. Your eyeballs are designed to detect electromagnetic radiation that's within the visible light spectrum. I mean, you see blue as one thing, you see red as another thing. And so if you had another organ that could detect gravitational waves,
we wouldn't have spent so many millions on LIGO.
Wouldn't have needed it, but you would have been able to feel the gravitational waves passing by, and you'll be like, oh, I hear two black holes merging out there in the universe. Or I can hear a truck coming my way.
It's
right?
true.
I can feel a truck moving towards me because I can detect the fluctuations in space-time. Cool. It'd be like Daredevil. You'd be like Daredevil, right?
Yes.
You could feel things moving in all directions. And you'd know how big they were and how far they were. So there you go. It's a new superhero. Just invented him. So Nancy Graziano says, so the difference between EM and audio waves is that a medium is not required for EM, but it is for audio, right? Yeah. Yes.
That's
you don't
one of
need
the
a
many
medium.
differences. Yeah.
Yeah. Except for the, what is it? The ether, what was the thing that they thought back in the...
It was ether. You had it.
Ether. Yeah, the ether, right? No.
E and M are happy unto themselves.
Yeah. William Vanderbeek is calling it Spidey sense. Yeah, Spidey sense. David Joseph Wesley asks, do you think the recent discovery of a super distant galaxy by Hubble will affect our current models for the age of the universe or the Big Bang?
Nope.
No, it was like really far, like 400 million years after the Big Bang.
But that's totally allowed.
Totally permitted. Yep.
It's part of us realizing that galaxies form both bottom up and top down, which means they both form little things that gather together into bigger and bigger things. And periodically you just end up with massive clumps of dust and gas. Go, okay, let's be a galaxy. And they just become a galaxy.
If you've calculated through the cellular method that human beings, start out as babies, and then you keep spotting younger and younger babies, but still, older than the youngest baby that you've calculated, it doesn't change your theory that there are babies possible. If you saw a galaxy that was 20 billion light years away, that would be a problem.
On so many levels.
On so many levels, right? So that, so as long as it's within 400 million, 13.4 billion years, no problem. 14.2 billion, now we got ourselves a problem. But of course, that's further than the cosmic microwave background, etc. So, let's see. So it's the luminous ether. Jason Rambo's notes. That's exactly right. Valdegas wants to know how many corn chips you'd have to eat before you became a black hole.
More than we have corn. You'd need to have at least 6 solar masses of corn chips.
Yeah, all collected in one spot, and then that would turn into a black hole of corn chips.
We have yet to have had enough corn exist on the planet Earth to create a black hole of corn chips in a naturally forming.
If you compress those corn chips, though, you could make a black hole out of corn chips.
One corn chip has the potential, if compressed enough, to become a microscopic black hole.
Right. Guido Bieber asks, would James Webb be able to look further back than Hubble, more than the current 13.4 billion years record?
No, because no, I mean, it won't be able to look back further in time because it's bigger. They're both limited in how far they can look back by physics. You can't look back before the cosmic microwave background, but Hubble is limited
only like
by
300,000. Yeah, that's only 300,000 years after the Big Bang, right?
So, Hubble hasn't integrated on one spot long enough to look back as far as James Webb will be like, snap, I got a picture of the beginning of the universe. So it's the Hubble has the potential to see stuff if it sits and integrates for enough years, but
right, but they're using Hubble and they're, those furthest ones, they're using gravitational lensing to get, they're using galaxies as boosters to be able to push the distance of Hubble further back.
Yeah.
James Webb will be able to do this stuff directly. Like, it won't even need to have some intervening galaxy cluster to act like a further lens. It'll just see what's on the other side all on its own. I mean, James Webb will go right to the edge of the observable universe.
And yeah.
Tom Nathy says that Alaska Airlines delayed a flight just to catch the eclipse.
It's true. It is
cool
actually true. It's the only no passport required way to see totality, from what I understand.
So cool. So it's happening today? Is that happening like...
Yeah.
Yeah. We've got some friends in Malaysia that are off to Indonesia to catch the eclipse, which is going to be great. So,
and our own Aviva Yamani, who's the producer of 365, she's doing a group of people to go see it in Indonesia.
Valdecast asks, is there a neutrino background radiation from the Big Bang?
I don't know.
Good question.
I'm tempted to say yes, but I don't know if it would be detectable.
Right, because at the earliest stages of the universe, the cosmic neutrino background is the universe's background particle composed of neutrinos, sometimes known as relic neutrinos. So, yes. There's a spammer. Spammer wants to tell us about an exciting opportunity that we have. What time is it now? I got 15 minutes. Lots more time. More questions. Hit us.
So the person asking, it scrolled, Elad asks, when will there be an accompanying lunar eclipse? So March 23rd, there will be a lunar eclipse. And there was one a couple of weeks ago, but it was stupidly early in the morning, I think.
Jason Rambos knew a stellar cannibal once. Real nice guy. Always invited me over for dinner. R.I. Instro wants to know Hypernova. What is it?
Hypernova, it's when a supernova is really big, and when it goes off, it directs a lot of its light along the magnetic poles of the star.
Is it like a mass thing? Like it has
the
largest mass stars, when they go off, and the way the physics of it goes, you get the magnetic field lines, it directs the beam at us, and we can be halfway across the galaxy and still get hit.
And I lied about the lunar eclipse. There wasn't one a couple of weeks ago. The next one is March 23rd. And then there's one again in September. This is actually a really lame year for lunar eclipses. We don't have any good total lunar eclipses this year.
So a couple of people had to use Google Translate to figure out what the spammer was trying to say. It's not very effective if no one can understand your spam. But they just know in their core. They can't understand the language, but they know in their heart that it's spam. Do we have any posts on YouTube? Anything on the Twitters? Are people tweeting at you with anything?
I have Voldegast saying post these shows on Patreon, but Voldegast, this isn't the show we have Patreon for. Patreon is for Learning Space, and all of the Learning Space episodes are posted on Patreon.
Yeah. No, I don't see any comments.
So
if there are no comments until the chat is done, I'm not sure how this works.
So let's explain our couple of Patreons. So Astronomy Cast is funded through your direct donations to Southern Illinois University, Edwardsville. We don't have any Patreon just because what we're doing works. I haven't changed anything. So if you donate to the show using the donate link on astronomycast.com, you are funding Susie, you are funding Preston, you are helping out with periodic travel and server costs. But Fraser and I also are trying to pay our salaries, and we do this show as a labor of love. But I do CosmoQuest and all of its activities off of a NASA grant, and Learning Space, which is our educational program, is funded through Patreon, and that is supporting Georgia and I putting together materials that help you figure out how to engage the small ones in your life in science. And we do things like periodic fireside chats, which are just open conversations where you can come in and talk to us. And then Fraser has a much more high-tech, geared at adults series that he can tell you about.
Yeah, well, so we do the weekly space hangout and also the guide to space on my channel on Universe Today. And then also, if you join the Patreon for Universe Today, you get no ads on Universe Today as well, which is cool. So no ads on Universe Today, and all kinds of other cool benefits. You get to see our shows early, things like that.
And we do have a rogue Astronomy Cast page we keep killing off. People keep creating Astronomy Cast pages for us, and it's very confusing.
On Patreon.
We will never ask for your money there, so that's not us.
Yeah, we get no money. Never taken a penny from Astronomy Cast.
Yeah.
Just tons of goodwill. And get to hang out with Pamela. That's the I want my honorary degree in astronomy at some point.
Yeah, I've tried to figure that out a couple of times and haven't yet.
That'd be awesome. Could we give the people who watch Astronomy Cast? How cool would that be? There are schemes afoot I can see in the chat to try and organize something about the 2017 eclipse. And we talked about this last week that, people want to do some kind of, live events, hangout, meet at somewhere in the Southwest and go to observatories and stuff like that. We'd love to do it. So, just let us know.
And we will be organizing something for the eclipse here in St. Louis.
David Joseph Wesley says, are you guys excited for No Man's Sky?
I don't know what that is.
Oh, I know what No Man's Sky is. Oh, I am, but I'm not. Because No Man's Sky is this procedurally generated game. It's going to have like 10 quintillion planets in it, solar systems that you can explore, and everything is procedurally generated. And so, the sun will be generated using math, the planets, and so you could visit any part of this planet and see weird, crazy situations that will exist nowhere else in this entire universe in this game. Theoretically, you can interact with other people, but the universe and galaxy is so big that you really never will, unless they have ways to sort of push people together. And so, but the life forms will look different, and then you, as the first person to discover them, will you get to name them, things like that.
That's cool.
Yeah, so I think it would be pretty spiffy, but then after a while you start to see like a bunch of different variations of dinosaur-y creatures, and then you're like, I think I've seen all the flavors of dinosaurs, of space dinosaurs. So no, I'm a little less excited about it than I think I should be. And maybe I'm just trying to manage my own excitement about this.
So it sounds cool, but yes, you can only have so many dinosaurs. Now, I do want to point out to all the people on the comments who are saying they want to travel Route 66 for the eclipse. Route 66 is like a block away from where I'm sitting right now. So Route 66 goes right through where we're planning our 2017 activities.
Yeah. Dudley Story says Mass Effect Andromeda delayed until 2017. Now that's a game I'm excited about. No, the one that I'm excited about, it's gonna be so nerdy, is the folks who do Europa Universalis, which is this game by Paradox that I really love. They're building a space-based sort of 4X game, and I'm really stoked about that because these people know how to make games that I really like. Like 4X? I like 4X Expand. I forget what it is. It's like Master of Orion, like these kind of space-based colonization games. And so Europa Universalis, in my opinion, is like the best sort of strategy game that's ever been made. It's way better than Civilization. Like if you like Civilization, Europa Universalis kills it. And so if those people are going to make a space-based one, Sign me up. So there you go. Expand, explore, exploit, exterminate. Yeah.
I love Civilization. So.
Yes, Civilization is garbage compared to Europa Universalis, is in my opinion. So it's so much fun, and I think I've got 300 hours in it. Yeah, it's a problem.
See, I don't have 300 hours for anything.
Neither do I. This is the problem. Yeah. The new Master of Orion is out, and the new Galactic Civilizations 3 is out. So, yeah. But no, my Steam library is way too big. And now, right, there's the new one, the Vive by Steam and HTC, and I really want that. I really want one of those. But they sold out like 10,000 of them in the first minute, and they're gone. So, and they're like $800. So this is a pretty significant investment, but it's like virtual reality. And apparently it's way better than the Oculus Rift. So I really want one. But I'm going to wait. I'm going to wait until they've been around for longer and people have tested them out and they've done upgrades to the hardware and stuff. So yeah, I'm excited about that. Enough about how come we always end up talking about video games? And
because that's our audience, and I am living vicariously through all of you.
Yeah. So for me, I just have I have kids, and so it's my excuse is that the kids and I will play games, and that's how I get to both be a parent and play all the video games.
My husband built a lightsaber on Friday. It's really loud.
Oh,
it's really, really
his
loud.
nerd award is in the mail. Which is awesome. Here we go. Here's a question about space. David Joseph Wesley asks, are we excited for Juno to reach Jupiter in a few months?
Yes.
That
one was easy.
Yeah. It's one of those, people forget, right? Like people forgot all about New Horizons until it arrived. They'd forgotten about Rosetta until it arrived, and they're going to forget about Juno until boom, it arrives.
And
these long missions.
Maven. No one ever remembers Maven, even though it's there, because it doesn't take pretty pictures. We need to remember the spacecraft that don't take pretty pictures.
And Mom.
Yeah, that one too.
R.I. Instro says, I get so much enjoyment out of watching other people play these games. This is this idea of Twitch and even on YouTube streaming. And this was a thing that I love so much, is how entertaining it is to watch other people play video games. I do it too. I watch people play Hearthstone because I'm not great at it, and I sort of watch other people play really good at it. That I think television. I don't know if I made this rant a couple of weeks ago, but people who come up with television shows never anticipated that the most interesting television would be to watch other people do a thing that you have a passing interest, but to do it really well.
Yeah.
Right? That's what watching sports is. You might have a passing interest in playing hockey or playing football, but you're never good enough to compete against other human beings, and you haven't dedicated your life to it. But there's something really wonderful about watching other people perform who are excellent at this sport. That is what sports is. And so now if you want to watch people play, I don't know, Dota, right, with incredible skill, it's super interesting. Or I guess like woodworking, or do art, or all kinds of things. So that's the new television.
Yeah, This Old House nailed it. And then somewhere people forgot that somewhere between This Old House and professional sports is a whole realm. And then there's Bob Ross for painting, and other networks need to catch up on what PBS figured out decades ago. Yeah,
exactly. Cooking shows, things like that.
Yeah.
All right, well, we've reached the end of our hour. Why don't we shut this down? I can even see there's like a little bit of a lag with me.
Yeah.
Do I need a faster computer? I think that's what I probably do. Even though I just bought a much faster computer, clearly it's not fast enough. I need to get more. David,
it was a totally unintentional pun. If I pun, it's probably not on purpose, and I drive Fraser kind of crazy with this.
Phil Plait is the intentional punster.
Yes.
Pamela's the unintentional punster.
It's true.
Okay, well, thanks everyone for watching. Reminder to thumbs up this video if you enjoyed it. And make sure that you subscribe to this YouTube channel if you haven't already, and then go further and set up all the reminders so that when we do our live show, you get reminded and you get to join us live. Thanks as always to Pamela, and we'll see all of you next week.
See y'all.
Bye.